Hi guys, in today's lecture, I will introduce Python basics to you. Note that this course is not a programming or machine learning course, so the purpose of introducing Python is to better demonstrate how can we realize AI or machine learning by coding. I don't expect you to get really good at Python programming, but it would be a great start point for you to learn Python, since Python is a user-friendly programming language and it's very useful for data processing, statistical analysis, and machine learning applications. Python is a programming language and can be used for different purposes. For example, data analysis, AI and machine learning applications, automation, web and software development, and the list goes on. Among so many different programming languages, such as R, C language, Java, etc., I prefer Python because it has many unique advantages. One is that it can work on different platforms, including Windows, Mac, Linux, etc. Second, it's simple and highly readable. Python is user-friendly. It has simple syntax so that developers can write programs with fewer lines than some other programming languages. And the code are highly readable and very similar to English. Another thing is Python can run on an interpreter system so that the code can be executed quickly. And finally, it has large ecosystem and huge community, so we can easily use the packages created by others or seek help from others. To download Python, I suggest you to use Anaconda, which contains the Python distribution and its code editor. If we download Anaconda, we simultaneously download Python with the most recent version, Python 3, and its IDE, or Integrated Development Environment, where you write, run, and debug your code. Some popular IDEs include PyCharm, Spider, Jupyter Notebook, and those IDE are all included in the Anaconda. To download Anaconda, you can go to this link, the website of it, and you can choose the corresponding version for Mac or Windows or Linux. Basically, to install the Anaconda, we can just use the defaulted options and click OK to move on to install it. One exception is this advanced option for adding Anaconda to the system path environment variable. If you are the first time to download Python, you can check this box. But if it's not the first time, you can leave it unchecked. And once you finish the installation, you can find Anaconda in the Start menu of your computer. You can also see the Anaconda Navigator, which is a GUI for managing environments and packages and launch applications such as Python IDE Spider or Jupyter Notebook. In this course, I will use Jupyter Notebook as the IDE for Python because compared with other IDEs, Jupyter Notebook can show the live code and visualization at one place, meaning that we can run the code one by one and see the results, while other IDE often run the whole book and show the results individually. So that might not be very easy for beginners. And let me show you how to launch the Jupyter Notebook later after I introduce the Python syntax. Okay, so that's all about the installation of Python. And before I illustrate how to use Python to realize machine learning, let's first get familiar with some basic syntax in Python. All the programming languages are meant to be readable and understandable by humans. but their syntax is defined in a way that allows to be translated so that the computer can understand it. However, the computer can only understand binary, meaning zeros and ones, which are switches in the computer memory. So, to get from human understandable language code to the machine code, it requires an interpreter to translate the language. And what's going on for the interpreter to translate your code to machine code is that the interpreter looks up for some tags or little markers or new lines or commas or periods to parse the code we write. I will introduce some important rules in Python, including the math operators, comparison operators, functions, string manipulation, indentation, and modules. I will use the Jupyter Notebook to show you the syntax. To launch the Jupyter Notebook, we can go to the Start menu and search Jupyter Notebook. And it will launch a new web page where we can see the contents. And we can find this icon that can be used to create a new notebook or a text file or folder or terminal. Here I will just create a new notebook with the kernel Python 3. Please note that don't close this home page. So here we can change the name of the notebook. For example, I will rename it as Week 3 Python Syntax. And this blank field is called a cell. You can use this icon to insert cells below. And here you can see this cell is for coding. We can also change the property of the cell to markdown, which means we can use a pound key followed by some texts to create the header for a section or subsection. For example, for the first section, name is math operators. If we run this line, it will generate a header like this. If I want to create a subsection, I use 2 pound keys. Also change the property to markdown and type the header name. So here we generate a subsection. And for this one, we can see this input sign before this field, and its property is code, meaning that we can type our code and run it here. So let me give you a very simple example. If we want to calculate 2 plus 2, we can run this line, and it generates the output is 4. So this is how we do the addition operation. I will add a comment using the pound key. Plus sign can do the addition. And note that here I added a comment following the pound key. And these comments are just annotations, meaning that they are ignored when we run the code. This means that whether we add or don't add this line, it will not influence the output. So that is the addition. How about the subtraction? If we can use the minus sign to do the subtraction operation. For example, 5 minus 2, the output is 3. And for multiplication, we can use the asterisk key. For example, 2 multiplied by 3. The output is 6. And if we use plus and multiplication together, we can find that the calculation will be done first for the multiplication and then for the addition. However, we can use the parenthesis to prioritize the addition. So we can see that the operation in the parenthesis take precedence. And another sign is very similar, but it has 2 asterisk key. This sign means exponent. So please differ the single asterisk key and the double asterisk keys. For example, so the output is 8, right? And finally, to do the division, we can use a forward slash. So that is about the math operators. We also have another set of operators named comparison operators. Comparison operators include the equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. For example, if we want to check if this statement is correct, the result is true, meaning that this statement is right. However, if we use the single equal mark, we'll get the syntax error saying that cannot assign to an operator. This is because the single equal mark means to assign a value to a variable. So these two are different. We can also check some other statements using, for example, not equal to, and the result is false. Such comparison operators are often used in, for example, the conditional statement, like we use if plus the condition, then, and else. So that's a comparison operators. The next syntax I want to introduce is a Python's built-in functions. A function is a block of organized code that is used to perform a single task. They provide better modularity for your application and usability. So let me give you some simple examples of the built-in functions. This function returns the absolute value of a number. For example, and this function is used to return an integer object constructed from the number or string. For example, we can use this function to change a string to integer, or change a float to integer. And this function can return the largest item. For example, we can assign some values to a variable called a. So I will create a list including several numbers. And then I will use this function to get the maximum number of this list. It's similar for min function. We can get the smallest item in this list. Another widely used function is called print. We can use it to print objects to the text stream file. For example, let's print a sentence. And another function is called type. This function can be used to check the data type of an object. The data type means, so in Python, the variables can store data of different types, and different types can do different things. Python has some built-in data types. For example, it has a text type denoted by string. It has a numeric type. Under this category, we have integer, or float, or complex. Python also have other types, for example, the sequence type, which contains list, just like this example. The A is a list, and it's denoted often by the square parentheses. And also tuple. So tuple is quite similar to list, but it uses normal parentheses. And also range. The next type is mapping type. Under this category, we often use the dictionary. It's like, for example, the variable called dictionary equals A, B, C, this is a dictionary, and it contains the key and its corresponding value, the second key and its corresponding value, the third key and corresponding value. So that is one example of dictionary. We can also refer the values by using the key. The next data type is set. Under this category, we have set, frozen, set, but this is not often used. We also have Boolean, and binary types like bytes, byte array, and finally, there is a non-type. So that is a simple introduction of the data type in Python. And to check the data type, we can use the type function. For example, we can check the variable A's data type. It returns list. So we know it is a list type of variable. We can also check the string, and it is a string type. Let me give you some other examples. So these three variables looks very similar. However, we find that B is of int type, C is of string type, and D is of float type. We can, so different data type are used for different purpose. For example, the numeric type can be used for calculation or comparison. However, the string type cannot be used for operation. For example, we cannot do C plus C. Oh, actually, this one here, the plus is not the math operator. It is a concatenate operator. So it just concatenates the string. But let me give you another example. We cannot divide C by C. So here it gives us a type error saying that the unsupported operand type string and string. But we can do such operation using the integer or float. So that is how the data type works. And the final function I want to introduce is a length. This function returns the length of an object. The object can be a string, like a sentence, or can be a dictionary, or a data frame, or a list. For example, we can check the length of the variable A, and it's 3 because we have 3 elements in this list. Okay, that's all about the function. And next one I want to introduce is the strings. I introduced the string data type before, right? So for this type of data or variable, we can manipulate some, for example, by we can index the strings, or slice the strings, or replace some of the elements in the string. So first, to indicate a string, we need to use a single quote or use a pair of double quote. They are the same. For example, we can assign the string value to the variable called B and check the type of B. So it shows B is a string. It's quite similar if we use the single quote mark. Okay. And in a string, we can use some notations to indicate. For example, use the /t to indicate tab, or we can use /n to indicate a new line, or line break. For example, here I will insert a new line using /n and a new line again. But here I will also insert a tab. If we run this, we can see here it has a line break again, and a tab. Another string manipulation is index. We can index strings by using the square parentheses. For example, I want to get the character at the location 0. So here we see it returns the character at the location 0. Note that the index in Python always start from 0, not 1. So here the H has the index of 0, and the E is with index 1, L 2, and this L is indexing 3. This one is 4, and this one is 5. The space is also takes also one location. So let me give you another example. If we want to get the character at the location 4, so it is 0 because 0, 1, 2, 3, 4. So it returns O. We can also use -1. It indicates the last one character. So it's this. And we can also slice the strings. For example, I want to get the substring of A from 0 to 3. And give you another example. They get the substring from the last 6 location. So here it gives us the first 3 characters, and this one generates the last 6 characters. We can also transform the case of the string using the function called upper. So that here we use a period to link the function and the variable. And all the characters will be turned into upper class. The next one I want to introduce is indentations. The indentations create a hierarchy of the code in Python. They are very critical. To add an indentation, we can use the tab key or space key. For example, we will use the indentation in the if conditional statement. So here, we have this indentation. This should not be ignored. If we don't have the right indentation, we can find this field will turn red. Python is very sensitive to the indentations. So for example, suppose we forgot the indentation here. It will give us the indentation error. However, I also want to note you that the spaces in the line of the cell of the code or a blank line in the code may not be necessary, but they contribute to the readability of the code. I mean, the space here doesn't make any difference. And also, whether we add a blank line here or not, it doesn't make any difference. Another point I want to stress is the case. Python is case sensitive, meaning that if we define a variable as v and define another variable as the upperclass v, these two are quite different if we, for example, print their type. So one is string and the other is integer. So always be careful when you use the variables. Note their cases, if they are upper class or they are lower class. And the final syntax I want to introduce is modules or import modules. What is a module? A module is like a code library. It's a file containing a set of functions you want to include in your application. The Python code in one module can gain access to the code in another module by using the import statement. There are several built-in modules in Python, which you can import whenever you like. For example, pandas is one of the most popular Python modules. It provides ready-to-use high-performance data structures and data analysis tools. It's popularly used for data science and data analytics. It allows us to store and manipulate tabular data as a 2D data structure. So, for example, we can import pandas or import pandas as PD. So we can just type PD here to indicate pandas. So, for example, we can read the data from a CSV file or Excel file using pandas. So if you have any CSV file in your computer, you can use this function, read CSV, and indicate the path. Let me give you an example. Let's create So now I have this Excel book. Yeah, I have this Excel book on my desktop. Then so I can type the location of it and add its name. Yeah. And note that in Python, we need to use double backward slash when we want to indicate the path. Or equivalently, we can use one forward slash. They are the same, but we cannot use the single backward slash. So now we already stored the table into this data variable. So we can output this one. And it shows the content of that Excel book.